Oh, the screen's not on. Nope. All right, so we are just gonna start right where we finished up yesterday. So we were looking at latitude and longitude, and I told you you had to do your side of the reading here on page 5 for longitude. So that was you guys over here, we're doing longitude, and you guys over here did latitude. And you were supposed to fill in the chart that is on page 7. And like I said, it's your lucky day if you didn't. This is everything you need to know for latitude and longitude. So these are your notes. What do you need? Oh, okay. So these are your notes for latitude and longitude. So please make sure you have these correct in your packet. So if you left it blank, make sure you fill it in. And you're supposed to leave some of it blank. So you guys should have all the longitude side blank, and you guys should have all the latitude side blank. But if you forgot to do your homework, make sure you fill it in. But the other key is that if you filled it in incorrectly, I need you to change it, because this is your notes for this section. So right off the bat, hopefully it was an easy one. Latitude people, what was the name of 0 degrees latitude? Yep, that's the equator. That is the only acceptable answer for that side. No, whoa, don't follow my rules over here. Sorry, don't make that mistake. So make sure you have 0 degrees latitude labeled the equator. Wouldn't want to screw anybody up there. Well, that's not going to work very well. Oh, well. What are they called? There's a fancy name for them now. Parallels of latitude. Oh, hang on, let me make sure I'm spelling this right. P-A-R, no, I'm not. What a mess. P-A-R-A-L-L-E-L. Parallels of latitude. No longer are they called lines of latitude. They're parallels of latitude. Which way do they go? They do not. These are side to side or horizontal. And you can see that here in the picture that I gave to you. See how these lines are flat? In fact, that's how I remember them. I call them flatitude lines. Latitude, flatitude. Or I've also heard them referred to as latitude, latitude. So they are like the rungs of a ladder, and you can climb up or down the globe on them. Again, this is what they'll look like. So I actually drew some of these in on a globe so you can see. These lines of longitude, when you look at them straight on like this, you can see that they make nice flat circles on the globe. But if you were to look at them from the North Pole, so if you could hover over the North Pole, see that they make nice perfect circles. Can you see why they're called parallels? So parallel lines are lines that never touch. So if you'll never ever touch a different line of latitude, if you're on one, it'll never cross a different line. Whereas, take a look at this picture. I know we're not there yet. Why are these not called parallels of longitude? They touch at the North Pole and the South Pole. What do the latitude lines measure? Degrees what? That was you guys, right? Degrees what? No, what were their labels? Degrees what? So we're looking for their labels. So if you don't know, since you weren't here or you didn't do your homework, flip back to the reading for latitude and see what they measure. Let's go back to the reading. Oh, it's the first line. Latitude is the distance in degrees north or south of the equator. That's what you put here, degrees north or degrees south of the equator. So it tells us, are we north of the equator or south of the equator? And the highest degree, what'd you guys find for that one? 90. 90 degrees north and 90 degrees south are the highest degrees. This is the North Pole and then the South Pole. All right, I'm going to do this class a little different than I did my other classes. Do you guys all have a ruler? There were rulers on the desks. Did anybody get a desk without a ruler? Look around. Are there desks that have rulers that don't have people? Oh, good. Oh, good. Who else needs one? Now everybody's got a ruler? Son of a gun, I don't have more. Look around. Are there more? Anybody see one? Oh, no. Oh, no. That's just not cool. Just one. What? Yeah, we'll have to share. All right. Because I don't even have one. I'll just have to. Hey, we only need a straight edge. So for me, this will work. All right. What I want you to do is grab your reference table, open them up to page 5. Page 5 is a map of the world. Here is the page 5. Now this, if you look at the title, this is a plate tectonics map. You guys that should sound familiar, tectonic plates. You guys should know they bump together. Mess with it. They bump together, they make earthquakes, they move around. That we'll get to later this year. But what we're going to do for right now is look at this because we want to look at the latitude and longitude lines that are here. So I would like everybody to put their ruler on the equator, please. And I should be able to look around the room and see that you know where this is pretty easily. So you're going to want to turn your paper so that the map looks like mine with tectonic plates on the top so that you are oriented the correct way here. So it looks like everybody's got that. I'd like you to take your ruler. Now, what's the numbers for the equator, by the way? 0. So notice there's a 0 on either side of this map. I'd like you to take your ruler and go ahead and draw that line in. Notice, so we talked about earlier that latitude lines are the flat lines. So we just drew in a line of latitude, a parallel of latitude, that's specifically the equator. I'd like to go ahead and label this equator. There's some room here in the middle that doesn't cover up any words if I label that. So that's the equator. It is a line of latitude. It is a parallel of latitude. It goes side to side across the paper. It is horizontal across the paper. And then remember that lines of latitude measure how far north or south of the equator you are. So over here on the right, I'd like you to draw an arrow up from the equator to the top of the map. anything that's up there is going to be north. So anything above the equator is north. And I'm going to go right ahead and do the opposite of that. Everything below the equator or south of the equator is in the southern hemisphere. So make sure you label it just like I did. Where I'm putting the labels is where I think they're the most useful. So that's the equator and the northern hemisphere and the southern hemisphere. How I'm going to have you find your degrees north or south are, so let's just find a place. Let's go ahead and we'll do this Hawaiian hotspot right there. We're just going to do a random spot. To find the latitude, and I know some of you have done this before, and some of you this is easy peasy. Some of you think you remember, but I want to start from the basics. Put your ruler on the equator. Now remember, latitude lines tell you how far north or south of the equator you are. So if you always start on the equator, you have to ask yourself, well, to get to Hawaii, do I go north of the equator or do I go south of the equator to get to Hawaii? Yep, I had to move my ruler up the paper, so I had to go north. So that's the first part. Hawaii is degrees north. Now you don't have to write this anywhere, but this is how I do it. I go right ahead and I write the degrees north first. So I don't have to think about it again. You guys, if you haven't established, like, I'm kind of scatterbrained and forget things, and I also don't like to think. So if I do this right now, I never have to think about it again. So if I label it right when I decide it, I don't ever have to remember it again. So that's the degrees north or south, and then you just have to go over to the side, and it doesn't matter which side you use. I like to use the right side because that's where I just labeled north. So if I follow this ruler over, it puts me a little above the 20, at least where I measured from. So what do you guys think we should estimate that as? 22 works for me. So then I go back, I already got the north part, so Hawaii's latitude is 22 degrees north. That's how I do it. Now let's go back and keep going with the packet. So that was the latitude, so sorry to jump around a little bit. Let's go do the notes for longitude and come back to latitude, or come back to the math now. What is the name of 0 degrees longitude? That was you guys on this side of the room. Prime meridian. The prime meridian is at 0 degrees for longitude. What are they called? So again, you guys over here are going to be writing this in, and you guys are going to be double checking your answers. They are just flat out called meridians. It's kind of boring. Oh, I spelled this wrong. I forgot some syllables. They are just called meridians. Which way do they go? They are vertical or up and down. Again, you can see this in the picture. Or if I grab, oh, this one just hasn't worn off, that's all. If I grab the actual globe here, these lines that go all the way from the North Pole, I'll draw a straight line, down to the South Pole. So there's one. Apparently it's hard for me to draw a straight line. So those are the lines of longitude, the different meridians. And again, like we said, they come together at the poles, so they all meet at the poles down at the bottom. They're not parallel. What do these measure? Latitude measured north or south of the equator. What do meridians measure? They measure degrees east or degrees west of the prime meridian. So it works just like the equator, it's just using the prime meridian as the base this time. And did you find the highest number? Come on, you guys. No, it's an actual number. Yeah. 180 is the highest longitude line you're gonna have, and this is called the international date line. We'll get to the bottom half of this in a minute, but I want to go back to our reference table. Do the same thing we just did. So back on your reference table, and here's the tricky part. Please do not write on your paper until we've determined you're correct. I want you to put your ruler on the prime meridian. Prime meridian. So guys, some of you got that wrong. What is the number for the prime meridian? 0. So where is 0 on this map? 0 longitude. Okay, Cynthia's putting her hand in a very weird spot because she knows it's over here. So the 0 on the top and the 0 on the bottom, go ahead and draw your paper in, or your line on your paper. I don't know why I just said that. That is the prime meridian. Eli, you got a problem with that? Yeah. Why is it not in the middle? That's just crazy talk, isn't it? So every other map you've ever looked at, I'm guessing in your entire life, has the prime meridian going down the dead smack center. And that makes perfect sense, because that way, if it's going down the dead smack center, you know to the right is east and to the left is west, and you never have to think about it. But the reasons people love to mess with you, and they didn't change the world, they didn't rearrange the globe. All they did is they drew this map from a different perspective. Normally, you're used to looking at a map. There's the prime meridian right there with the blue line. You're used to looking at it like this, where you're dead smack on, looking at the prime meridian going down the center. All they did is they took the picture of the map when the prime meridian was over there. Still the same world, just drawn from a different viewpoint. They do this again. Could they have given you the easier map? Yes, of course. But they want to make sure you can read a map no matter what it looks like. We're not always going to have the prime meridian on the maps, first of all, and it's not always going to be down the middle. But it still works the same way. The prime meridian determines if you are in the east or in the west. And you guys know your compass, right? Never eat soggy worms. Worms. Okay, so I disagree. So if I have to eat worms, they better be crispy. I'm saying if I have to, I can, yeah, like I'm going with deep fried, tempura style. Like I could choke down a soggy waffle. Not sure I could choke down a soggy worm. Just saying. But if it's crispy, like a potato chip, maybe I can handle it. Okay, not important. I just like to mess with you. So you guys know never eat soggy whatever. So it works the same way. On a normal map with it in the middle, everything to the right is east. Well, the same thing here. Here's the prime meridian. Oh, can't see that, sorry. Here's the prime meridian. Everything over is east. So everything to the right. Yes, it does look like just a small section. Is that the only place now that's in the Eastern Hemisphere? No. The world is round, or officially an oblate spheroid. We talked about that. But it just connects. See how this number is 20 right there? See how that number is 20? It's the same line. So the map should be like this. And then maybe that would be easier. But it's the same line, because can you see Africa? There's that part of Africa. Well, there's the rest of Africa over here. So again, it just looks weird, but it's really not that bad. So that's east. And then so is over here, all the way to 180. So I'm going to include another line going from the left to 180, and I'm going to label that east. Now, again, we're used to looking in this corner for North America. Just be careful when you're looking at the map. North America's over here. So I'll also say, guys, I've been doing this for a lot of years. Label it like I am. There's a reason for that. So put the east at the top. And a lot of people get confused. Well, isn't the top of the paper north? These numbers over here are measuring your norths. These are the south. These measure how far east or west of the prime meridian you are. This section here is the west section. Most of you know that we are the Western Hemisphere. Western medicine is modern, new age, or like new medicine. Eastern medicine is the stuff that they would practice like in the Middle East or in India or China and things like that. They're over here in the East. Mr. D is a good way of remembering this. Do you guys know where they drill for oil? What part of the world? No. East, the Middle East, right? That's where we get a lot of our oil from. Countries like this. Not countries like North America. Our oil doesn't come from North America. It comes from the Middle East over here. So just one way to like quickly check your work. Well, if you're in the United States, we are not in the East. We're in the West. So this gets a little confusing, but it's not horrible. We're not going to do all of your homework, but I want to go ahead and do a couple examples with you. So as you notice, your homework's on page 9. So page 9 has a chart and then 5 questions. We're only doing the chart. So your homework is the chart, not the 5 questions. We'll get to those next week. But the first one asks you to do Florida. And it asks you to do the latitude, then the longitude for all of these. I know some of you think you can do this your own way, and I'm sure some of you can, but I'm going to walk you through how I would do it to get it right every single time. Latitude always comes first. The way to remember that is if you do it alphabetically, LA comes before LO. So you do them alphabetically, just like when you do coordinates on a graph. X is first and then Y. That's again alphabetical. So we do the first thing is to find Florida. Technically, Florida is not labeled on here, so officially the Regents would never have you do Florida. But most of us know that Florida is over here in the handle little area of the United States over there. I put my dot on the very bottom tip of Florida, so could you guys go ahead and do that too? So I just put a dot right there on Florida, which is in the upper right-hand corner, the little handle part of North America. Here's how I want you to do it, or here's how I would do it to get it right every time. Latitude, latitude. Put your ruler flat on the equator. And then, just like I said before, decide, do I have to go north or south to get to Florida? You do go north. So again, I had to move my ruler from the equator north. Again, I write this now. I go back to my paper and I write degrees north because I don't want to think about it in 3 minutes from now. I want to just get it out of the way now. That's what I do. So I just wrote degrees north. Now I can read the numbers. Now again, because I have my paper flat or my ruler flat, I'm going to be reading the numbers over here, not the ones on the top of the paper. Follow the ruler over, and these are the numbers I'm reading over here. What would you guys estimate Florida to be at? So I heard some people say 30. What else did I hear? I couldn't hear you. 25 works too. So 25 is halfway between the 20 and the 30. I think that's probably more accurate. 20 is definitely too low. 30 for me gets me above my dot, so I'm gonna go with 25. So then again, I go and I write. I already wrote the degrees north, so I don't have to do it again. Same thing for longitude. Now you're gonna take your ruler and put it on the prime meridian. I froze my camera. Of course I froze my camera. I bumped it. Dumb thing. All right, well, so do the same thing for the prime meridian. Take your ruler, put it on the prime meridian. Decide, are you gonna go east or west? Oops, still frozen. You're on the prime meridian, do you go east or west to get to Florida? West. So you take your ruler, line it up, and I'm gonna have trouble because my paper's not straight up on the board. So like I said, I would have gone in and wrote that degrees west before I kept going. And what number do you think Florida lines up good with? I would go with 80. 79 works as well. Well. All right, well, I'm not gonna be able to show it on the screen anymore. But that's okay. One more time. Hey, look, it's working again. Nope, hey, it's frozen again. What a pain in the butt. All right, so that's Florida. Now I have another question for you. The next question's Buffalo. Why does it have to freeze? Do you know where Buffalo is on this map? Not really. What country? Yeah, which continent? North America. Woohoo! North America. Do you guys know that we're right near Lake Erie and Lake Ontario? They're the two smaller lakes. So for Buffalo, you're gonna put a dot right basically at the tip of those two lakes. That's Buffalo. Everything else on your homework is actually labeled. So like another one of your homework on your homework will be the Tasman hotspot right there. We got the Yellowstone, Galapagos, Canary Island. I'll let you guys search for them, but the rest of them are labeled. But we're not doing our homework now. We have to go back to page 7 and finish the notes. And hopefully, nope, it's not gonna let me finish them here. Screen share. Okay, so down on the bottom is the important stuff about latitude, and I'm guessing most of you did not read the bottom of page 6. On the bottom of page 6, where it says measuring latitude, it says at night in the northern hemisphere, latitude can be determined by measuring the altitude of Polaris. The altitude of Polaris is equal to the observer's latitude. Polaris is not visible in the southern hemisphere, so altitudes of other stars must be measured to determine latitude. So that is what we need to focus in on for today. We need to talk about the altitude of Polaris. So before we even get too far, does anybody have any idea what Polaris is besides a snowmobile? Never heard of it? From the reading, what do you think it is? It says at night. It's a star. So one thing, I think you have some room down here at the bottom of this picture. Let's put that note. Polaris. In fact, it's got a name we're used to hearing it. It's like its normal name is the North Star. So I just wrote Polaris equals North Star. You heard of the North Star before? You should have. I know you've all heard of it at least once in your life. What is the North Star for? To guide you where you're going. Last class, someone mentioned that the slaves, when they were escaping in the South, they would, when they were on the Underground Railroad, they would follow the North Star. And where did it bring them? North. So the North Star is a fancy star. Any idea which star is the North Star? That is what I was hoping you'd say, Cynthia. Most people think so, since it was so important that the slaves used it, and it was the slaves, they could do it with very little education. They could follow the North Star. The North Star must be pretty easy to find then, right? Yeah, it's not. Okay, it's not the brightest. It's not the first one out. The North Star, the only thing fancy about the North Star is it lives directly above the North Pole. Sorry. Yeah, I know, sorry. So it lives right here. It's the only star in the sky that appears to stay still. So that's why you can use it. All the other stars in the sky appear to move. So if you try to find some other star and find your way, well, sometimes it's going to be over there. Sometimes it's going to be over there or there or there. But the North Star always stays in the same spot. So if you follow the North Star, you are always going to be walking north. And that's what the North Star did for the slaves, and it could still do for you. If you go outside and you find the North Star and you always make sure it's straight in front of you, you're going to be constantly walking north. So the North Star didn't really get them there. It just made sure that they were staying on a north path. So how do you find the North Star? You can use constellations. Have you ever heard of the Big Dipper before? Have you ever seen it? Kind of, I agree with that statement. Have you ever heard of the Little Dipper? Have you ever seen it? The Big Dipper and the Little Dipper, they're kind of easy to find. The Big Dipper is way easier to see than the Little Dipper. So first of all, why do they call them dippers? They look like something you could dip with. I would have called them Big Ladle and Little Ladle, but that doesn't sound as good. So they look like things that you scoop soup up with. Apparently in the olden days, they called those dippers. I guess I see where they're coming from, but I would have called them ladles. In the Big Dipper, which if you can, over the next week or so, go outside and see if you can find the Big Dipper. what people have told me today that they have an app. I use an app called the Night Sky is the name of it, and it actually connects all the constellations for you so you can see them. It's pretty cute, cool if you have some room on your phone. It's free. Download it. You can delete it later, but it is kind of neat to look at the stars. These two stars in the cup of the Big Dipper, they point right to the Little Dipper. And so this one right here is the North Star. And the reason this is helpful is this bullet right here. Altitude of, and so put this in your notes. The altitude of Polaris is equal to a person's north latitude. So altitude of Polaris equals your latitude. So not only does it stay still, it also tells you your latitude. If you know how high the North Star is, so if you find it in the sky, because you find the Big Dipper and it points right to the North Star, if you figure out how high it is, and they do it in degrees, straight out is 0, straight up is 90. So if you know, you can estimate your angle. So for us, it's 42 degrees north is our latitude. So 42 degrees north means that Polaris is 42 degrees in the sky. So for those of you who are going to take me serious and go out and look for the Big Dipper and the Little Dipper this weekend, you have to look north, approximately 42 degrees in the sky. So keep in mind, straight out is 0, straight up is 90. So about halfway is 45. You're looking a little less than that. So it should be north in the sky about here-ish. Just make sure you're doing your angles better. I think it's more like this is 42, but it's hard to say. So over there in the northern sky, use the app, it'll help a lot. This is really important because if you know your altitude of Polaris, you know your latitude. If you know your latitude, you know your altitude of Polaris. This is important. Put a huge star there because this will be on every test, every homework, every quiz, every lab, and I've seen it on literally every Regents I've ever corrected. You need to know that the altitude of Polaris equals your latitude. That's it. We'll get to the bullets for longitude next time. Do not forget to do the top part of page 9.